Okay, this is your material over 6.3 and 6.4. I have combined both sets um, just to make it a little bit easier. But for your homework, you will have your sets split up. So you'll have a set of homework over 6.3 and then a set of homework over 6.4. Okay. All right, but I'm going to go ahead and combine both of these lectures because I think it's a little bit easier. All right, so our learning objectives are we're going to illustrate sets with 2 and 3 circle Venn diagrams. We're going to review how Venn diagrams can be used in probability. Now, even though we have not touched on probability, it's very simple. Okay, solve a variety of problems using Venn diagrams. And this should say studying sets. So you should put an S there. That was a typo. Studying sets with 2 and 3 circle Venn diagrams. Okay, so the first part says write the appropriate description next to each region. Pick your answer from the following list. Now, all we have to do is just answer A, B, C, or D. We don't have to rewrite, absolutely everything. All right, so region 1, and notice where region 1 is. It's in circle A, but outside of circle B. So it says the elements in set B that are not in set A, the elements in both sets A and B, the elements in the universal set that are neither set A nor set B, the elements in set A that are not in set B. So region 1 is in set A, but not, because remember, this part is part of set B. So it's only in set A, but not set B. So that's going to be letter D. Okay. Now, region 2, well, where is region 2? And we're going to go ahead and mark this off because we're only going to use these once. So region 2, look at where it is. It is in set A and it's also in set B. So the elements in both sets A and set B. So that's going to be B. Okay. All right. Now region 3, well, that's going to be just the opposite of region 1. Region 1 said that it was the elements in set A that are not in set B. So that means that for region 3, it would be the elements that are in set B that are not in set A. So that's A. And then by default, the last one's going to be C. The elements for the elements that are neither in set A nor set B. Okay. All right. All right. Now it says illustrating a set operation with Venn diagrams. So step 1, draw a diagram for the sets with Roman numerals in each region. Use the Roman numerals. List the regions described by each set. Step number 3, find the set of numerals that correspond to the set in the set operation. And then number 4, shade the area corresponding to the set of numerals found in set 3. Okay. That sounds like a whole lot to do, but we're going to do this a little bit easier. Okay. So here's what I'm going to do. And I didn't think about color coding these before I printed them out, but I did color code the other ones. All right. So set A, this is going to be in red. Okay. And I know you're not going to probably be able to see this too good, but this is set A. It's red. Set B is going to be blue. And the reason why is that when we shade these regions, we're going to be using these colors to help us see where they overlap for the intersection or for the union, okay? So it says draw a Venn diagram to illustrate the set A union B prime prime. Okay, well, A union B prime. So A means everything that's in set A. All right, so that's all of this. This is everything that's in set A. Okay. And then B prime is everything that is not in B. So it has to be outside of B. So it's all of this. It's just not, we cannot include B. Now be careful here because here we can include, oh wait. Nope, can't. This is just set A. Sorry about that, guys. Okay. All right. So set B, B prime is everything that is not in B. So I'm just going to skip all of this. And so all of this is not in set B. Now it says it's A union B prime. Well, the union is everything. So if it's A union B prime, that's everything that's in A and everything that is not in B. So that's what we've got. Now we want the complement. The complement of all of this is going to be what is not in A and what is not in B prime. So if it's not in A, that means it's got to be outside of A. And if it's not B prime, it has to be in B. So outside of A, including what is in B. And so that's going to give us this part. And so notice that this is going to give us region 3 because it is, let me show you something in just a second. Another way to understand what this is saying is this actually means A union B prime prime is the same thing as everything that's not in A that intersects with B. So it has to be common. So what's not in A that is common with B? Well, even though all of this would be not in A, B is not over there. B is right here. So it's just going to be this part, which is region 3. Okay, that's our answer, is region 3. All right, now let's look at the next two. The next two says to illustrate the set of A prime intersects with B. A prime intersects with B. So A prime is everything that's not in A. Okay. So again, here's A that's red. So not everything that's not in A, which is all of this. And I don't know if you have already caught on to what's going to happen here. because we just answered this question. Okay, so that's everything that's not in A, along with whatever is in B. So B is going to be all of this. Now, region 2 is still in B. Okay. And so what's not in A that intersects with B, not in A, but it does intersect with B. So not in A and B. So outside of A, including B, is going to be this. And so the reason why we did this is so that you could see what we just did. The example that we did before was A union B prime, prime. Okay. And look at what we shaded. We shaded region 3. Now, when we illustrated A prime intersects B, notice what they have in common, and that's region 3. All right, so it's the same thing. So that's how we know that A union B prime prime is the same thing as A prime intersect B. Okay, so the complement of a union is going to give you the intersection. All right, that's what that means. Okay, now let's look at this one. So we have A prime. So let's go ahead and do that. So A prime is everything that's not in A. So this is not in A. Sometimes it takes just a little bit of time and you have to be patient. Okay, not A. Okay, not A. And then we also want what is in B. So not A along with B, which is this. So I want everything that's in B. Okay, now what are we looking for? Well, we're looking for the union. The union says that it wants it all. It wants everything that's not in A along with everything that is in B. So I want all of this, not A. I know this is going to take a long time. I'm trying to hurry. So here is not A along with B. Now notice that I cannot shade the part where B is inside of A because the first part says that I don't want what is in A. I want what is outside of A. Okay. And this is my answer. What's in yellow, orange, is my answer. So that means we're going to have region we have region 3, and region 4. We do not have region 2 because region 2 is part of A, and we strictly have to have what is outside of A. Okay, so that's how that works. Okay, now on a separate sheet of paper for extra credit, I want you to do the following. So on a separate sheet of paper, prove both laws. You will need to create two Venn diagrams, one for each side of the equal sides. Okay, the point is to show the diagrams are the same. So De Morgan's first law says it's the union of A and B complement is equal to A prime intersect B prime. And then the intersection of A and B complement is equal to A prime union B prime. So you're going to show a Venn diagram for this and this, and you're going to show that they are the same, and the same thing for De Morgan's second law. Okay, so that's going to be extra credit. All right, and then I'll tell you in class whenever I want this turned in. Okay, so now let's look at how we are going to be handling our Venn diagrams. All right, so it says in a survey of 100 randomly selected freshmen across campus, it turns out that 42 are taking a math class, 51 are taking an English class, and 12 are taking both. How many students are taking either a math class or an English class? One of the things to understand is that the 12 students taking both classes are counted twice. Therefore, they must be removed to avoid being counted twice. Okay, and I'll explain that as we go. Now, when you have a setup like this, the first place that you want to go for is the intersection. And I've already labeled the circles. One, this one's math and that one's English. Okay, so the first thing I want to do is, did they give me a total set of people? Did they give me my universal number? And it said in a survey of 100 randomly selected freshmen across campus. So they did. So my universe is going to be 100 freshmen. Okay, so remember at the end we have to count, and we hopefully inside our universe we're going to end up with 100 students. Okay, now the next thing that I'm going to look for is the intersection between math and English. And did they give me a value for math and English? And it said that 12 are taking both. Okay, so if 12 are taking both courses, then that's my intersection. This is going to be 12. Okay. Now, it says that 42 are taking a math class. So let's look at this for just a second. I have 42 students that are taking a math class, but if you look at your math circle, I can't put 42 here because notice how I already have some people that are included. I already have 12 people that are taking both math and English. Okay. So what we're going to do is we're going to subtract this 12 from the 42. So 42 minus 12, that's going to give us 30. So we know that 30 students are taking math only. Okay. All right. Now that you've done that, can you figure out how many students are taking English? Well, actually, I should have done this in red, so I'll let you figure that out while I change this to red. We're going to have 42 minus 12, which is 30. Okay, now for English, it says that 51 are taking an English class. Okay, but in that English class, we already have 12. So that's 51 minus 12. So that's going to give us 39 students that are only taking English. Okay, now that's all the information that I have. So I need to know, is this going to total 100? Well, 30 plus 12 is 42. 42 plus 39 is 81. So I'm short 19 people. Okay. And the ones that I'm short, I'm going to put out here because they are not taking either. Okay, so now I have all 100. Now, this says how many students are taking either math or English. Now, 12 are taking both, so it's not going to be 12. So how many are taking math or English? Well, 30 are taking math and 39 are taking English. So all I'm going to do is add those together. They just have to be taking one or the other, or they could be taking, well, no, if they were taking both, they would be counted among the 12. So that means 69 students are taking either one of those courses. Okay. How many students are taking only English? Well, only English would mean that it's just 39 students. And then how many are taking only math? Well, that would be the 30. And then the last question is how many are taking neither? And there are 19 students that are not taking either math nor English. Okay, so you always start with the intersection. Okay, now let's go to number 4. In 2019, there were 41 states that had some form of casino gambling in the state, 45 states that sold lottery tickets of some kind, and 38 states that had both casinos and lottery. Draw a Venn diagram to represent this data and find out how many states have only casino gambling, how many states have only lotteries, and how many states have neither. Okay, so I think my questions are kind of messed up. All right, so first, we're going to label these. So we're going to say that the red circle would represent casinos. So that's just C. And the blue circle is going to represent lotteries. That's L. Okay, now, did they give us a number for both? It said there were 41 states that had some form of casino in the state. 45 sold lottery tickets of some kind. 38 had both. Okay, and that's where I want to start, is right here where it says that 38 states had both casinos and lotteries. Okay, so that means 38 is going to go here. Now it says 41 states had some form of casino gambling in the states. So 41 states had some form of casino gambling. Okay, well, in the casino circle, I can't put 41 because I already have 38 there, so I'm going to have to subtract. So 41 minus 38. So that leaves us with 3 states that only have casinos. Okay. And then 45 states sold some, 45 states sold lottery tickets of some kind. Okay, so if that's 45 minus 38, and that's going to be 7 that only sold lottery tickets. Okay, so now this, I'm going to add the 7, the 38, and the 3. So 7 and 10, 7 and 3 is 10. 10 plus 38 is 48. Now, they didn't give me what my universal set is. And we're talking about states. So how many states represent the US? And that's going to be 50. So that's going to be our universal number, 51 United States. 50. So if 48 are represented here, 50 would be our universal number, then that means we have 2 states that do not have any form of gambling. So how many states have lotteries and casinos? Well, that's the intersection. So that's 38 states. And let's see, there was another one. Let's see, let me go ahead and highlight. Let me get a different color. Let me get a purple. I don't know that this is going to show up, but these are the questions that we were supposed to ask. I don't know how I ended up messing this up. So how many states have only casino gambling? Only casino would be 3. Okay. So then how many states have only lotteries? Well, that's going to be 7. How many states have neither? And that's going to be 2. And I think we had to answer that down here. Okay. So, yep, there are our questions. Okay. So hopefully this isn't difficult. You just have to be very careful in how you do this. All right. Okay. Now, here's what I want you to do. For class, I want you to finish this. I want you to do 5, 6, and 7. And we're going to do this the first thing when we're back in class. Okay. So you set up your diagrams. Now be careful because the last 2 are 3 circles, but they work the same way. Okay. You always want to start with the intersection and then start working your way out. Okay. So I'm going to leave this here. I am not going to, I will later post the entire solutions, but this is all that you're going to get for right now. Okay. Because I want you to try this for class. All right, guys, I will see you later. Bye-bye.